Key takeaway: methane is a powerful heat-trapping gas. An estimated 60% of today's methane emissions are the result of human activities. Methane basics. Methane is a powerful greenhouse gas and is the second largest contributor to climate warming after carbon dioxide CO2. A molecule of methane traps more heat than a molecule of CO2, but methane has a relatively short lifespan of 7 to 12 years in the atmosphere, while CO2 can persist for hundreds of years or more. Methane comes from both natural sources and human activities. An estimated 60% of today's methane emissions are the result of human activities. The largest sources of methane are agriculture, fossil fuels, and decomposition of landfill waste. Natural processes account for 40% of methane emissions, with wetlands being the largest natural source. Learn more about the global methane budget. Concentration of methane in the atmosphere has more than doubled over the past 200 years. Scientists estimate that this increase is responsible for 20 to 30% of climate warming since the Industrial Revolution, which began in 1750. Tracking methane, although it's relatively simple to measure the amount of methane in the atmosphere, it's harder to pinpoint where it's coming from. NASA scientists are using several methods to track methane emissions. One tool that NASA uses is the Airborne Visible Infrared Imaging Spectrometer, next generation, or AVIRIS-ING. This instrument, which gets mounted onto research planes, measures light that is reflected off Earth's surface. Methane absorbs some of this reflected light by measuring the exact wavelengths of light that are absorbed via virus. ING instrument can determine the amount of greenhouse gases present. NASA added the Earth Surface Mineral Dust Source Investigation (EMIT) instrument to the International Space Station in 2022. Though built principally to study dust storms and sources, researchers found that it could also detect large methane sources known as super emitters. These aircraft and satellite instruments are finding methane rising from oil and gas production, pipelines, refineries, landfills, and animal agriculture. In some cases, these measurements have led to leaks being fixed, including suburban gas leaks and faulty equipment in oil and gas fields. The Arctic is a source of natural methane from wetlands, lakes, and thawing permafrost. Although a warming climate could change these emissions, scientists do not yet think it will drive a major increase. To this end, NASA's Arctic Boreal and Vulnerability Experiment, or above, has been measuring methane coming from natural sources like thawing permafrost in Alaska and Canada. Data notes and sources. NOAA's methane data comes from a globally distributed network of air sampling sites. gml.noaa.gov/ccgg/trends_ch4/iScore data are from Law Dome, Antarctica, and Summit, Greenland ice cores from Etheridge, DM, LP Steel, RJ Francie, and RL Langenfelds. Atmospheric methane between 1000 d and present. Evidence of anthropogenic emissions and climatic variability. Journal of Geophysical Research, 103, D13, 15,900, and 79 to 15,993, 1998. Data archived at the Carbon Dioxide Information Analysis Center, CDIEC.es-dive. l.gov/trends/atm_meth/lawdome_meth.htm emissions that observe methane, Earth surface mineral, dust source investigation, EMIT, Airborne Visible Infrared Imaging Spectrometer. Next generation AVIRIS-ING, Arctic Boreal and Vulnerability Experiment, above GeoCarb launch date 2024.